Get the recording going. All right. Well, welcome everybody to the third Groton Long Point Road Bridge Task Force meeting. Just quickly go through the roll call here for the task force members. I just go by who I see on the screen here. We have Frank Boland, Ray Rafferty, Andre Bumgardner, Clarence Casper, Dave McBride, and Portia Borderlawn. For staff, we have myself, Greg Hanover, Director of Public Works, John Burt, Town Manager. And then we have from AECom, our engineers, consultant engineers, we have John Hapwitz and John Ives. Well, thank you everybody for attending tonight. At the last meeting, we kind of reviewed the elevations for flooding, sea level rise. We talked a little about roadway widths, bike lanes. Andre had some good comments on that. We're going to go over that tonight in some detail. And also, John Ives has prepared a presentation to really kind of get into some of the design standards that are going to be required for the profile and review the profile in respects to sea level rise, and also the right-of-way or property impacts, particularly for the houses on the north side of the road in Noack. And we'll hopefully be able to, get some good input from everybody so we can kind of give our engineers some guidance to proceed with some design work here. So, and I also put in on the agenda just to talk briefly about after we get through all the technical stuff, just a little bit on the website development, where we are with that and how we want to proceed with that. So with that, I'll turn it over to John Ives. You can go through and kind of give us your presentation, John.
All right. I'm sharing my screen here. All right. Is everyone seeing the title page of the presentation?
Yep.
Yes. Okay, very good. All right. You know both of us at this point. As Greg mentioned, we'll quickly go over the roadway typical section, and then we'll really delve into the profile tonight and what the design criteria are, so everyone has a good background on that, and what the right-of-way impacts are of meeting that design criteria or some kind of compromise thereof. And then hopefully that'll generate some discussion on and give us some direction going forward. So that's the major goal for tonight. The typical section we discussed briefly last time. The minimum width for the roadway here will be based on CONDOT design criteria and construction staging, and we come up with the same width needed for both. We're proposing two 11-foot lanes, two 5-foot shoulders, which will double as bike lanes, and one 5-foot 6-inch sidewalk. And the limits of where that sidewalk starts and ends in relation to the project limits are to be determined. Right now, we're assuming that the sidewalk is in the, basically starts at the bridge and continues east to Esker Point Beach. So we are incorporating the bike lanes within the shoulders. And are there any questions or comments about that? Very good.
Current width of the road, as I measured, it was 32 feet.
So yes, it would be, right now your roadway does not have a sidewalk on it. It does have some extra wide barriers. They have that little safety curb, let's call it, like a narrow curb. Maybe it's about 2 feet wide or less. So we have a slight widening that's required for incorporation of the sidewalk. It's also required for stage construction. In order to build this bridge with alternating one-way traffic in the first stage on the existing bridge, while we construct half of the new bridge and then flip that traffic to the newly constructed half of a bridge while we construct the second half of the proposed bridge. A slight widening would be required. And it just so happens that that widening is equal to the width that we need to meet basic CONDOT design standards for lane width and bike lane width. So there's no
Jonathan?
extra overbuild for construction staging, and at the same time we're minimizing the width, which is what we want to do here because width is cost. So
Hey, Jonathan.
Andre,
Yes, great great presentation so far, and thank you for sharing this information with us. Sort of curious to see, can there be any attempt to even lean the existing lanes? Currently, it's looking like it'll be 11 feet wide going in each direction, which I think is great. But obviously, there are some roads that are 10 feet wide. And they, the wider the road width, the more likely it would induce higher speeds. And so, my question is, could we make an attempt maybe to look at a 10-foot lane direction in each way and have a 1-foot painted buffer between the bike lane and the vehicular lane?
that's a good question. And I understand your concern. You do have a straight shot of road, and I guess that could lead to higher speeds. Do you have any experience in the town with, at this location with excessive speed in the past?
Well, I know this.
Not necessarily you, Andre, but also Greg or
I'm sure Dave
Has
will be able to answer the question best, and Clarence. I know they use that road way more frequently than all of us combined. So I certainly want to respect their point of view most of all. But considering that, again, that road is coming from a state road, and obviously once you hit that bridge, you do want to encourage slower speeds once you get into to Groton Long Point. So that would be my only other comment on that.
Yeah, this is Dave McBride. That's a great point. I'm glad you brought that up. I would say in the busy season, it's not, people slow down because it's busier, but in the off season, it does. People tend not to slow down once they cross the bridge, the bridge from the rail bridge. So if that was feasible, that would be something we should probably consider.
Yeah, this is Clarence. I do go by there almost every day, living in Mountford Cove. And I think cars do go slower in the summer. There's kids on the bridge. It's narrow and people do slow down. I think coming into Groton Long Point, cars are tending to go slower because they're coming up to a stop sign anyway, and the speed limit's 25. It drops to 25 just before, as you come around the curve just over the railroad tracks. But leaving, I think sometimes people do speed up from the stop sign in the off season and go over the bridge faster than 25 miles an hour, but not much more.
And this is David again. Do we know what the width is currently as a comparison?
I just told you, I measured it at 32. Bolin measured it at 32.
So there's no change in the actual width of the lane from the current, it's 11 feet currently. Is that safe to assume?
Probably, I'm gonna guess at 12 foot now, because that's pretty standard from state highway design back in the 50s, 60s, and 70s when it was,
Okay.
put in.
Forgive the scrolling. This is what I had for the existing condition.
Yeah, it's a
12-foot lanes and 2-foot 11-inch shoulders. So, and you do have striped shoulders out there now. So,
Yeah, that's about right.
Thank you.
Yeah, I can also check with our police department. I know we did a traffic study or account study a couple of years ago at this location for this project. And I'll see if we actually captured, average speeds and stuff as well, if that is helpful to you, John.
and I can offer this too. If, what we're showing is the minimum width that we think we need for stage construction. But if you had 11-foot lanes and 5-foot bike lanes, nothing would stop you. Even if that's what the state said, okay, why can't you have 11-foot lanes? Nothing would stop you from coming back later and striping that buffer zone if you wanted to.
Mhm.
If you striped for 11-foot lanes and 5-foot bike lane / shoulders to start, and that was what the program made you do, you could always come back and change that. With striping is easy, right?
Yeah, yeah. In the summer, you could even put some cones down to effectively narrow the lane and keep the separation.
All right.
Did you have another
So we'll
question,
consider
Andre? I
that
see your hand up. No, okay, thanks.
Yeah, we'll consider that going forward. All right, so for the profile, we started talking about this at the last meeting. And to start, I just want to kind of quickly rehash the criteria. And we did get some new information and guidance from Condon. So let me move ahead with that. So because we want to get this in the federal local bridge program to get that 80% funding, that does necessitate the use of CONDOT design criteria. And the hydrologic and hydraulic criteria will affect the profile because that's going to set our minimum elevation with relation to the design flood. So based on the drainage manual and the watershed size, that dictates the design event, which is the 100-year return period event, frequently referred to as a 100-year flood. And the drainage manual says you need 1 foot of freeboard. Again, that's the distance from the water surface elevation to the edge of road, to the low point on the road, or 1 foot of underclearance at the bridge. That's the distance from the water surface to the bottom of the superstructure, the bottom of the beams that carry the road over the channel.
Was that an or?
And it's an and. So at the bridge, you're going to have additional freeboard, but along the roadway, you have to have, say, away from the bridge, you have to have that 1 foot of freeboard. Obviously, our structure is going to have some depth to it. So at the bridge, you're going to have some, based on the drainage manual requirements, you're going to have some extra freeboard. You need 1 foot minimum freeboard and 1 foot minimum underclearance. So freeboard is meant for the roadway. Freeboard is the distance from the edge of road or gutter line to the water. And Under
in this-
clearance is
in-
at the bridge.
Right.
So-
So I'm sorry, in this case, the freeboard really has no meaning. Because in order to
If
give
you
you,
had a flat profile, Frank, if you had a flat profile, then the freeboard would have no meaning.
right,
But typically your bridge is kind of in a hump in the vertical curve.
oh, I see, I hear you, okay.
So your roadway could be lower away from the bridge, right?
Gotcha.
And as we said before, the design criteria can be waived or relaxed based on economics, environmental impacts, constructability, and right-of-way impacts, which come into play here.
Maybe for clarification as well, what we're talking about here is not just the bridge. It's
Yes.
also, it's the roadway coming to and going away from the bridge, right?
Right. So within our project, we're going to have to address a certain amount of roadway on either side of the bridge just to make up, a reasonable profile.
Sure.
So you can't pick up the bridge and not pick up the causeway adjacent to it. So
I have a question. This is Clarence. What is the, where, I mean, the 4 point whatever, was that 4.5 square miles of, the watershed size, 4.2 square miles. What's that based on? Because it looks like, to me, in this case, the flooding is coming from the ocean side or the sound side and not
Right.
from the freshwater side.
that's a good question. Even though that this is a tidal situation, what CONDOT uses as criteria for the size of the structure is the watershed size. So you have a 4.2 square mile watershed north or inland of the bridge. And by their manual, that makes this an intermediate structure. And all that really does is it dictates how much freeboard and how much underclearance you need. If you had a larger watershed, they would be looking for more underclearance. So the fact that it's tidal doesn't change that in this case. Does that answer your question?
Yes, it answers my question, but it still doesn't make sense.
I'm laughing with you, not at you. The hydraulics are kind of a dark art, and it's not my specialty. I'm a bridge engineer, but that's their requirement. So,
If I can just break in for a second, the problem is, this is a subject that warrants a little bit of discussion as we get down the road. But one of the problems they have in many of the structures is the post-storm effect. They can't do much about the ocean. It's there. That water is gonna get in, it's gonna fill up the cove. But then after the storm goes by, the ocean goes down and you've got a lot of water in the cove that's gotta get out. And if you look at failure along the shoreline, the majority of the failures that you see have happened from the inside out. The structure has fallen into the ocean because they couldn't get the water out. They couldn't support the load from the water in the cove. That's the concern.
Yeah, so that would be a later discussion.
Right.
okay. So the design water surface elevation based on the drainage manual comes from FEMA, and the latest FEMA flood insurance study has a 100-year still water elevation of 9.7. So for a frame of reference, the low point on the existing causeway is about elevation 8. And high tide is around elevation 1, give or take. So, given that 100-year still water elevation of 9.7, the elevations required to meet the ConnDOT drainage manual requirements would be, 1 foot of freeboard would give you a minimum edge of road elevation of 10.7. And 1 foot of underclearance would mean the bottom of your structure would be set at 10.7. And, as Frank alluded to earlier, you have some structure depth there. In this case, if we're clear spanning over the existing structure, building a longer bridge founded beyond the existing abutments, our depth could be about 4 feet. And that would give you a minimum profile grade at the bridge all the way up to 14.7 feet. And that's pretty far up from where we are now. And that's understood.
What are we at now, John? Just so people have a point of reference.
Around at the bridge, I'm going to say we're close to that 9.7. We may be just a little bit under it.
All right, so raising the bridge about 5 feet.
Yeah. Yes.
The boaters will love you.
To meet the drainage manual requirements, which again are, even though they list them as requirements, they are subject to consideration for economic realities. So we talked about sea level rise at the last meeting, and I got some clarification from Michael Hogan, who is the head of ConnDOT's hydraulic unit. ConnDOT does not currently require that design water surface elevations be adjusted for sea level rise. Now, that does not mean that we're not going to consider sea level rise in design, but by their standard, their reference elevation is the elevation, the 100-year flood elevation in the current FEMA study. That's their current standard. So there is the Public Act, Act 18-82, which strongly recommends that you consider sea level rise in your planning. And basically what this boils down to is the town is free to exercise judgment in how you account for sea level rise. And again, the recommended sea level rise is 0.5 meters, which is 1.64 feet or close to 20 inches. And it's thought that that is the projection for year 2050. So I dug further into the FEMA flood elevations, and this top list here is showing the 100-year still water is 9.7, as we discussed. So that means that every year there's a 1% chance that you'll have a flood event that reaches elevation 9.7. The 50-year still water elevation is 7.6. Means every year you have a 2% chance of hitting that elevation. Likewise, 10-year elevation is 4.9. That means you have a 10% chance of a flood event that's at that elevation. And mean high water is 1.21. So all of these, the 100-year, 50-year, and 10-year are theoretical design storm events and corresponding elevations. If we add the recommended sea level rise to those elevations, we get these numbers down below here. And this is, just projecting that the still water elevations will rise with the sea level rise. And we can, as a suggestion, we can design to the requirements of the drainage manual, which are, giving you a roadway that's dry for the 100-year event. And we can see where that leaves us for, given the projected sea level rise for year 2050. So to incorporate that sea level rise in the design water surface elevation would put us at such a high elevation that it would have a severe effect on the rights of way. And we'll get into that later on. So I guess the point I want to make now is you do not have to incorporate sea level rise in the design water surface elevation. It should be a consideration, and the designing for the 100-year event is still designing for a theoretical flood. It's still conservative. The sea level rise is a conservative projection that we can consider in our planning for the causeway and bridge, and make sure that in the future we're still in good shape, without necessarily going overboard and planning to have a structure that is dry for the 100-year event in year 2050. And just adding conservatism onto conservatism.
John.
So I'd like to look. Go ahead.
The proposed roadway elevation that you just got through talking about is 14.7 feet.
We're not proposing that yet. We're just saying that is what you would need to be at the bridge to meet the strictly meet the requirements of the drainage manual.
Understand. But that's well in excess of your 11.34. So the road is going to be dry in the 100-year storm without adding another 1.5 feet to it.
If you were to actually design for that 14 feet and change, I think you'd have some severe right-of-way impacts. So I want to look at those first.
Okay.
Because I know that a compromise will be required here, and or I believe that one will be. So kind of building up what are the ideal design requirements, and what are the resilience issues that we want to look at, and then now what are the right-of-way issues? That's the next. And then we'll have a discussion, hopefully, about what the best path forward is. So here's your project. We have some, basically a long flat causeway. Elevation is above 9 at the bridge. We know it drops down to about 8 to the west. And what we've done is taken a look at some, what the effects would be on these property owners if we raised the roadway up to meet just meet the freeboard requirements of the drainage manual. So for reference, this home on the southwest corner here is, let me see. I think that's 1000 Groton Long Point Road. And then I think we have 991 Groton Long Point Road here, and 981 Groton Long Point Road is the closest property to the bridge. And so I sent out to this group some separate figures so that you could look at these in detail outside of the presentation. This is where we've cut cross sections. And so we have section AA is at the driveway here at 1000 Groton Long Point Road. Section BB at the next driveway, and CC at the next house. Likewise, DD and EE at the next driveway and house to the east. Here we have the existing profile of Groton Long Point Road. Here's our bridge and our 5 cross sections that we cut at these houses and driveways. And yeah, I'm sure these figures may be hard to see on Zoom, but I've got some more to follow up. The elevation in front of these houses, as you can see, or I'll tell you, it's between 9 and 8 here. And then we've got the blue line here is the 100-year still water elevation of 9.7. The green line is the 100-year still water elevation plus the 1 foot of freeboard that the drainage manual would recommend. And then the red line above is the 100-year still water elevation plus the sea level rise, which brings you all the way up to 11.34. Here are our cross sections. And what you're looking at is a section taken, it's like a slice taken transverse to the road. This dashed line is the road. And you're looking east toward Esker Beach. And the dashed line is existing, and what's up here, the solid line work is proposed. This first section is at a driveway at 1000 Groton Long Point Road. And it looks like if we're to set the roadway for the 1 foot of freeboard here at elevation edge of road at 10.7, we can match in, okay, we're picking up the road a little bit in front of this house, where we can blend in before the property line and the garage. Section BB is at 991 Groton Long Point Road. I go to the map here and take a look at 991 Groton Long Point Road. You can see the aerial is in need of update on Google, but here's the current house here. They've got a very expensive Belgian block driveway here. And to meet that minimum 1 foot of freeboard at the edge of road and be at elevation 10.7. This is what the change would be to the driveway here. What we're showing is, looks like I have this in my PowerPoint presentation here. About close to 3 feet of fill. And the driveway would get quite steep. So normal design standard for a driveway would be about 12% grade. And in this case, to have a shelf and a swale in front of the structure for drainage, we're showing a 25% grade on the driveway, which is at most like a 4-to-1 slope. So pretty substantial slope. And likewise in front of the house, which is shown on the next cross section, showing here we're showing a 6-to-1 slope because the shelf is not required. But again, about 3 feet of fill in front of this house. And here's the view of the house from the roadway. And then the next dwelling and the last one before the bridge here is 981 Groton Long Point Road. And that's section D and section E. Here we're showing a 20% slope for the driveway. Looks like about close to 3 feet of fill. Again, a 6-to-1 slope from the roadway down to the house. That means that a 6-to-1 slope is considered to be a maintainable slope for a lawn, which is kind of another design standard. But that means that also the whole front lawn down to the house will be filled. And again, the whole driveway would be reconstructed just to meet that slope, which is at 20% is well beyond the desirable 12%. Now there are a lot of driveways in the state that are well beyond 12%, I'm sure. It's just CONDOT's design standard. And so these cross sections are basically, they're just meant to convey, if we try to meet that 1 foot of freeboard for the 100-year flood, what the changes are going to be to these properties and what the right-of-way impacts are going to look like. So we'd be grading well onto the lawns here and redoing these whole driveways. We're filling the road in front of the houses by about 3 feet. And that's substantial and I think worth discussion. And this next slide here just gives you the approximate fill required to meet that 1 foot of freeboard. And this is assuming that we get a design exception from CONDOT and don't provide 1 foot of underclearance at the bridge. If we provide that foot of underclearance, we'll have to extend that profile out well beyond the bridge to get up to elevation 14 at the bridge. And so these fill depths would increase. So at the same time, so we have our CONDOT design requirements, which can be waived based on right-of-way impacts and economics. We have our projected increase in sea level. And we have our residents, our homeowners as a consideration. And we need to find a balance and decide what's most important to move ahead with the profile. We need to know what's acceptable for right-of-way impacts, and that's really what I'd like to open up for discussion here. So,
Yeah, this is Clarence. I wonder if instead, I understand the driveways have to be sloped, but is it necessary to slope the lawn or just to provide almost like a wall of, instead?
it's a good question. We could provide wall. It's just cost. We could provide walls and and landscaping to, that might be a discussion with the homeowner.
And also, is it much more costly to relocate the road a little bit more south? It looks like it could be a possibility also.
What would be the goal of relocating the road to the south?
It gives those two houses a little bit more room from the road.
I guess looking at it at this plan view here, this aerial photo, what I see is a house on the southwest corner that's very close to the road. And so that first property, which is almost across the street from that house, it'd be hard to give them any relief. And I'd just advise that pushing the whole causeway to the south would be, I would expect that to be expensive.
You bet. John, I have a question.
Yes.
The elevation profile from the bridge, I understand the bridge, we're standing at 14.7 or something like that. Did you carry 14.7 all the way along down to where? When you're figuring the properties, the elevations are somewhat lower at those properties than the bridge elevation, right?
What we've done here is to just show the existing profile and the flood elevations and where these sections are cut. So we don't have a proposed profile on here. You can see from this figure that the current bridge is between 9 and 10 at the top of road. So let's say 9.5. And what we've done on the cross sections is to just assume that we're minimizing the profile change to provide that 1 foot of freeboard only and not the 1 foot of underclearance.
Sure.
Saying this might be some kind of compromise, and okay, because this is definitely an attainable compromise, what would the right-of-way impacts be? Or do we have to go even further and not provide, the 1 foot of freeboard? This is for open discussion, but we haven't developed a profile that meets the strict requirements of CONDOT, because we know that they can be relaxed, and we know that looking at these sections, which already have large right-of-way impacts, when we're just trying to get to 10.7, that if we try to get all the way up to 14 to over 14 at the bridge, the right-of-way impacts are going to be so much greater that we'll be talking about takes instead of slope easements and driveway reconstruction.
Right. Well, if you look at the circuit conditions when we have a 100-year storm, a number of those properties are underwater anyway. B, the bridge, the existing bridge surface is just about dry in the 100-year storm. And the roadway, as you proceed south and west towards the stop sign, goes down to a low, so that you've got some amount of water on the road in the 100-year storm.
In the current condition, again, that roadway profile is about 8, and the 100-year storm is 9.7. So the roadway is impassable.
Right, exactly. But the bridge is just about passable. The bridge surface is you're about at
Yes.
the 100-year level, 9.7 or something like that. So this is an interesting question, how you go at it. I mean, by my eye, the red roof guy, the first one we run into on the north side of the road as I'm coming to Groton Long Point, Mumford Cove, is the worst. It's the lowest lying, and so I'd expect to have the slope being greatest in that area. I also think that if you raise the roadway up significantly, that's the house. That I'm saying that you're cutting their view off. it's that
Right.
low. You're cutting.
If you look at this house and what was here previously was a single-story house, and you can see that, you know, with the new construction, the house has been raised up again, as Greg mentioned to me offline, probably for flood insurance reasons. Could also be for the view. But any house that's reconstructed here, which I expect this is happening in this area, people are probably buying some of these older properties and leveling them and building newer, bigger houses. They'll be built more like this with, I'd say a garage on the first floor, or a first floor that that can survive the flood without ruining the house.
Well,
and then the
breakaway
main dwelling
wall.
is up here.
Yeah, the breakaway, the lower level, I think is getting into the requirements for breakaway walls.
Yeah.
But let's go back to what it is we can do, how much latitude we have as a committee. If you're telling me that CONDOT, it requires us to have a certain elevation in order to qualify for money, what is that? Is it 14.7?
So I can speak to what we've been able to do on other projects, not necessarily coastal, but where we've been able to show substantial cost or right-of-way impact, we have been able to get waivers for these criteria of underclearance and freeboard. I would say that typically at a bridge replacement, at the very worst, we're going to match the low chord of the existing bridge. We don't want to be any lower than the existing bridge. So the existing bridge has a low chord elevation of about, so either 5.6 or 5.7, so it's substantially lower. We're talking about picking up, let's say if we had that 1 foot of freeboard as a target, and we said we're going to get a waiver for underclearance. We were at 10.7, and we had a clear span structure that's about 90 feet long. And then that structure is going to be 4 feet deep. And that puts us at 6.7. You know, we can probably be a little bit higher at the bridge because we have some room. Sorry about that. We have some room between the last house and the bridge to build up the profile. But we have to find that, you know, that middle ground between resilience and cost and right-of-way impacts. So this was just, these cross sections are for, you know, kind of discussion and consideration. You might look at these right-of-way impacts and say, okay, even that is more than we're willing to do. And that.
Well, if I had to pick a number for a road elevation, for a road surface elevation, it would be on the order of 11.34 feet, which is what I think you told me was the 100-year storm plus 1.5 feet of sea level rise.
Yes.
Do you show me that in one of those red, white, and blue?
Yeah, we did on the profile. We had the 3 lines. So
That's it. So
yeah, if you look at this grid, this is also a 1-foot grid. So you can see, you know, on here, and you can also just do the math. But you know, at
so it's the red guy, right? Is that 11.34, right?
Yep.
And which is substantially below, that's 3 feet below 14.7.
Right.
So
you'd be keeping the roadway dry, and you'd have, you know, even considering the sea level rise, you don't have the extra 1 foot of freeboard in year 2050, but that's okay. You can still see the road when you're driving off, you know, off the peninsula during the 100-year flood.
Right.
And that was what, you know, that would seem to be a good target. It's just finding the best solution for these properties. With that, if we're picking it up, so what you're suggesting is to pick up the road a little bit more than what we're showing on the cross sections that are here. So, you know, I think you're beyond looking at slopes. We talked about walls a little bit. You still have the driveway to consider, and it is going to be a pretty severe impact to those property owners.
Let's go back to the property owner profiles. I guess I'm not clear on what you used as the elevation for that. Was the worst case, was that 11.34?
So here we showed 10.7, which is just the current 100-year still water elevation.
Right, okay.
1 foot of freeboard.
Yeah, I get
and one thing that I'll go back to it in the presentation. We said we want to consider the sea level rise, and let's see. That was the point of this slide. So
yeah,
you can see, you know, obviously all of these are theoretical events. The 50-year event plus sea level rise is 9.24. So if you were at that, say if you were at that 10.7, you'd be somewhere between the 50 and 100-year event, projecting for sea level rise to 2050.
Okay. That 14.7 then doesn't even enter our discussion.
In my opinion, it's just too much.
Oh, yeah, I agree
Unless
with
you're,
that.
yeah, if you want to do takes there. Yeah.
Yeah, but
And again, that would be at the bridge and you try to minimize it as you got away from the bridge. But if you're
Sure.
talking about doing that to have a perched structure, it
Sure,
wouldn't
no,
make a lot of sense.
No. But I must have misunderstood or not heard. I thought you came up with that number because it satisfied conduct requirements that we had to pay attention to in order to qualify for federal monies.
You're, if you satisfy all of their requirements, then there's no discussion with them. If
Right.
you can't satisfy their requirements, then you have to show good reason why you can't. And certainly looking at the right-of-way impact here, that is,
Clear.
that's your, that'll do
Clear.
it.
Okay, so 14.7 is off the table. So now we're
Right.
looking at something like possibly, if we said we'd wanted the road dry for access in the extreme event, the 11.34, and the drawings you were showing us in profile were pretty, looked like some pretty substantial hits.
Yeah.
And the elevation was only 10.7 or something like that,
That
right?
was 10.7. So you can look at it this way, if you design for the 100-year event now, theoretically, in 2050, that'll be closer to the elevation of the 50-year event,
That's right.
which is the 2%, a 2% chance of that storm every year instead of a 1% chance.
I have a question. This is David. Is it worth looking into seeing if they would be, flexible on the reimbursement rate if we weren't to go so high? Because I am concerned about those 3 property owners and what repercussions they're going to have on this project. I mean, is there some flexibility on what we could do to not so severely impact them, but still fix the bridge, which is how this all started?
Yes, I think that even the right-of-way impacts that we're showing on the sections, CONDOT would accept something less, less than meeting that 1 foot of freeboard. But I know that the resilience is a consideration for your committee, so just.
That is a major consideration of the town council, so we do have to weigh that also.
There's other solutions to resiliency though, other than raising the causeway, right? Aren't there other options to consider?
What are they?
Well, you can't build walls or breakaways or things like that?
I
don't
think
know.
another consideration would be your planning. You have a some system in place for emergency evacuation, and you just have to consider what you'll know what the causeway elevations are and what event is going to cause that to be impassable. And certainly you want to try to make an improvement if you can. And that would be another way to go about it.
I mean, in this day and age, if
From
you're
a
aware of
resiliency perspective.
coming, can't you make changes to safeguard that causeway?
You can make changes to safeguard the, how robust the causeway is. Part of this would be, adding heavy riprap to protect the, certainly the seaward side from wave action during a storm event. But elevation kind of is what it is for right-of-way impacts.
And I guess my question would be, and I'm I don't have much knowledge on this, but what repercussions could there be from these three landowners, if any, from this program? I mean, are we severely impacting them? Are there any legal issues we need to consider, or is this something we don't need to worry about?
Oh, I think you'd want to engage the property owners.
And so
You
maybe
will
we'll
have to engage them during design. That will be, and you know, that's an obligation of the program. Their right of way would have to be acquired. If you're, you know, even if you're not taking their property, if you're impacting their property, you will have to work with them, either through the town or through the state. The state will do that for you through the program if you choose to go that route, but they will engage the property owner and negotiate with them for their to
Okay.
compensate them for the change.
So is that something we should begin to do now?
I think that's up to the town. I would engage them sooner rather than later. You might get a feel for, I don't know, what the feedback is going to be during design. I think you don't want to be surprised by it down the road.
Yeah, I think at this point, you know, John, we can reach out to those three property owners. I mean, we went down the same path when we reconstructed Crystal Lake Road, and that was a DOT project as well. And we worked at their rights of way. They did all the takes and everything, but we did, you know, engage the property owners fairly early on. And you know, DOT did all the appraisals and got all the rights of way needed. But I think
Right.
we would probably be looking at that same approach here.
Yeah, they have the conduct rights of way. They are like basically a real estate division. That is their expertise, and they're used to dealing with it. They know how to appraise the properties and what they're worth, and they're used to dealing with the homeowners. And there's no reason not to allow them to do that, especially if it's federal local bridge program. You know, they'll handle it as part of the program. And then there isn't even a cost associated with having them do that.
But there will be a cost to the project to, you know, compensate the property owners for any
That's
damage.
right. Yes. It's feasible that you could do this with minimal profile changes. However, you have your resilience considerations.
I would say in terms of profile, the recognizing that a fair amount of Groton Long Point already is underwater in the 100-year flood event. That if you're thinking about anything less than mass evacuation when we have a forecast for a 100-year event, however good that may be, you have to think about emergency vehicle access. And so that I would say that road elevation, if you ever were thinking about just replacing the road, that would be unacceptable. That you're going to have to raise the road in the vicinity of those houses to some extent anyway, because it's too low in the extreme event. It gets wet now. What we're talking about is taking it up to the extreme event plus, and that's that'd add another foot or foot and a half to it anyway. So it's resilience And of course, don't forget that red house is going to be underwater in the storm, and then we get into whether you rebuild it or not.
Right.
So there's a lot of issues that are floating around here. I don't think we should think about leaving the roadway the way it is. It's going to come up. The question is how much. And what governs how much it comes up. If you're telling me the conduct does this or does that, or it affects our funding of the project one way or the other, then another whole set of factors come together.
Right. I think that the increase in profile grade is more of a resilience issue than a funding issue because
Very
of the
good.
severity of the right-of-way impacts.
That's good. So right now, at least on my scratch sheet, I have it, we're ranging between 10 something, which is what you had on the drawing, John, and 11.34, which is going to make it much worse in terms of impact. Probably not a lot of gain in terms of quote resilience, access for emergency vehicles, because we got a lot of roadway already underwater right and left of it. It sounds to me like the number you're working with is pretty close to that 10.7.
Which, correct me if I'm wrong, John, but that 10.7 meets the conduct criteria.
It meets the freeboard
Because
criteria,
they
but
don't,
not the clearance. And that's, I
they don't
think
take into
that is that's okay. I mean, we see that underclearance requirement not met pretty frequently. If there's good reason for that structure to be, under pressure flow or not have the freeboard that's desired.
Now, the other thing is the bridge could be a little bit higher, right?
Yes.
We could have, as it is now.
Right. I mean, right now, the bridge is at the low chord elevation is in the 5s. So you're well underwater for the 100-year event. And
Oh,
for
yeah, but not the surface of the roadway.
Yeah.
Not the surface of the roadway.
The roadway, by the numbers here, having a low elevation of 8 would be 1.7 feet underwater at the low point.
Yeah, maybe.
right, but I'm thinking along the lines Frank is, if you keep the bridge a little higher, which you need to do for drainage on the road anyway, you can't have a perfectly flat road.
Right. I think,
Just
with
kind
just there are so many variables here.
Yeah.
That what we tried to do on the cross sections that we gave you is just show you something at each house, knowing that if we're going to have the 1 foot of freeboard, which you'd like to have just to make sure your roadway is dry during the 100-year event, that would be the minimum impact on that property.
Right.
And so we tried to be at about that elevation at those houses. Some are going to be a little bit higher than that, and then have a little bit of an up and over at the bridge.
Okay.
And yep, that would be the goal in the profile development if we are sticking to that as our design criteria.
Not much more to say. You got all the impediments laid out. Now the solution.
The solution is some kind of balance. So it's understandably there's a lot of competing interests here, and I'm sure the property owners where they on would have some different opinions. So.
Okay, so maybe one of the next steps is we should see if the town can reach out to the property owners and start a discussion.
Well, I think you're going to have to take some hard options to them in terms of profile, cross-section and elevation.
Yeah, I'm thinking that 10.7.
Yeah. I think that'd be a good one to work with.
So we could refine our, our plan. I know the cross sections can be difficult to look at and show some cut and fill lines and some more detail at those properties, so you could have something to take to the property owners to discuss.
Okay, does anybody else have any comments, questions on this profile? Or pretty much beat this to death tonight?
Well, that's how we get this thing moving forward. So.
Yep.
So if we can nail down that profile, and it sounds like we have some direction on that, then we can move ahead. And then this doesn't change really from the last meeting, and we're basically on schedule. Hopefully talk to those property owners and get some feedback and get into design this year as soon as possible.
Okay. And John, I did want to touch on the website development. I know, we still have that web page active out there, and we're trying to get the emails redirected to myself, which we're working on.
Greg, yeah, we do have control of the website now, and as of today, there is some a filter set up, so you should
not
stop
get
getting random blank emails.
Yeah. All right, and then how about getting some of the this new data uploaded on there, kind of bringing up that more current, because looking at the we're recording all these meetings, and that we do have them on the town's YouTube or GMTV website, and you're looking at today, we've had quite a bit of interest. We've had 48 people, which doesn't sound like a lot, but compared to some of the other committees and commissions that are out there, we're actually probably one of the more popular meetings that people are looking at. So it tells me there's a lot of interest in this project, obviously. So I want to make sure we get as much information out there as we can.
Sure.
So as soon as we
I'll
can
coordinate offline with you on what you want to show on the website.
Okay, that'd be great.
Does anyone else have any other questions? Okay.
All right, no other questions? Okay. Well, next meeting will be February 18th. And I don't know if we'll have had a chance to talk to those property owners by then or not, but we'll try. And then I also want to, I think, start talking about the next item, which of interest will be the sidewalk. Whether that goes north, south side of the road, limits of sidewalk, all those good things. So thinking about that. So if there's no other questions, I guess that's it. Thank you, everybody.
Thank you.
Thank you.
Thank you.
Thank you.
Thank
Stay
you.
stay
Good
well,
night,
folks.
everyone.
Happy New Year. Stay well.
Take care.
I got
Thanks,
my
you too.
shot